Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0497, indicates an issue with the evaporative emissions control system, specifically low purge flow detected from the EVAP system. The evaporative emissions control system plays a crucial role in minimizing fuel vapors released into the atmosphere from the fuel system. This system typically consists of components such as the EVAP canister, the canister purge valve, the fuel tank, and the fuel filler neck. Each element ensures fuel vapors are captured, stored, and purged back into the engine for combustion, thus reducing harmful emissions. Understanding the components' functionalities and their locations is essential for effective troubleshooting. In this case, the low purge flow suggests that there could be a blockage or a malfunctioning component, preventing the proper release of vapor pressure. During the diagnostic process, it is imperative to utilize special tools, such as a vacuum pump gauge and a vacuum gauge, to accurately assess the system's condition. The DTC P0497 specifically indicates that the EVAP system is experiencing low purge flow detected, signifying potential issues within the evaporative emissions system. The primary components affected include the EVAP canister purge valve, the fuel tank pressure FTP sensor, and the accompanying lines that connect these elements. The EVAP canister is generally located near the rear of the vehicle, often near the fuel tank, while the purge valve is typically located in the engine compartment, connected to the intake manifold. The FTP sensor is often integrated within the fuel tank. Each component plays a vital role. The EVAP canister collects fuel vapors, the purge valve controls when these vapors are sent to the engine, and the FTP sensor monitors the pressure within the system. A thorough understanding of these components, location, and interaction will guide the troubleshooting process effectively. Several potential causes of the DTC P0497 should be considered during the diagnostic process. One common cause is poor electrical connections at critical components like the FTP sensor or the purge valve, which can lead to inaccurate readings or system malfunctions. Additionally, blocked or damaged hoses in the EVAP system can prevent the proper flow of fuel vapors, causing low purge flow conditions. This includes issues at the connections between the throttle body and the EVAP canister, as well as blockages within the hoses themselves. Furthermore, a malfunctioning purge valve that does not open or close properly can also contribute to low flow. All these factors should be systematically checked to identify the fault. Understanding these possible causes allows for a targeted approach to troubleshooting the vehicle's emissions system. The presence of DTC P0497 typically manifests through certain symptoms. One prominent indicator is the activation of the check engine light, CEL, on the dashboard, alerting the driver that there is a malfunction that needs attention. Another common symptom is a failed emissions test, which can arise as low purge flow results in higher levels of emissions being expelled from the vehicle, failing regulatory standards. Additionally, drivers may notice a fuel odor, indicative of an issue in the fuel vapor system. While these symptoms are primarily observable, they serve as key indicators for technicians diagnosing the problem. Addressing these signs promptly can prevent further complications related to the emissions system and ensure vehicle compliance with environmental standards. The first step in troubleshooting DTC P0497 involves verifying the problem through initial checks. Begin by turning the ignition switch to the on position, I, ensuring that all vehicle systems are activated without starting the engine. Next, use the Honda Diagnostic System, HDS, to clear the DTC from the system. Clearing the code allows for fresh data collection as you proceed. After clearing, it's crucial to select the EVAP test from the inspection menu and perform the function test with the HDS. This test assesses the operability of the EVAP system and helps determine if the issue is consistent or intermittently occurring. If the result indicates that the system is functioning properly, further investigation is needed to check for potential loose connections or terminals affecting system performance. And the next troubleshooting step should be initiated. For the second troubleshooting step, turn the ignition switch to lock 0 to ensure all systems are off while conducting checks. The next action requires a visual inspection of the EVAP canister purge line. This line runs between the throttle body and the EVAP canister and must be assessed for poor connections, any potential blockages, or visible damage. A blocked or damaged line can hinder the proper flow of fuel vapors, leading to low purge flow. If the inspection shows the line to be okay, you can confidently progress to the following step in the troubleshooting process. However, if any damage or blockage is detected, it is necessary to make the appropriate repairs to the line before continuing with additional diagnostics. In the third troubleshooting step, you will identify the possible failure area by first disconnecting the vacuum hose from the EVAP canister purge valve. This step is crucial for determining if the issue lies within the valve or the line connected to it. Once disconnected, connect a T-fitting with a vacuum gauge and a vacuum pump to the hose, which will enable you to assess the pressure accurately. With the ignition switch turned to on second, apply a controlled vacuum of about 2 kPa, 0.6 inches per second, to the hose. Then, using the HDS, perform an EVAP test to evaluate the function of the purge valve. Observe whether the vacuum is maintained or released immediately. A rapid release would indicate further issues, requiring you to continue diagnostics, while stable vacuum suggests that attention should focus elsewhere in the system. During the fourth troubleshooting step, the focus shifts specifically to the EVAP canister purge valve itself, necessitating a thorough examination of its functionality. Begin by executing the EVAP PCS, purge control solenoid, off with the HDS and disconnect the vacuum hose. Subsequently, connect a T-fitting, a vacuum gauge, and a vacuum pump to the purge valve to facilitate the assessment. Apply a vacuum of 2 kilopascals, 0.6 inch H, to the purge control solenoid. Then, re-engage the EVAP PCS on via the HDS and observe if there is an immediate vacuum release. If the vacuum remains stable, this indicates the purge valve is functioning properly. Conversely, if vacuum release occurs prematurely, indicating a malfunction, the purge valve must be replaced. After any repairs or replacements, ensure a verification process is completed to confirm system integrity. In this step, connect the vacuum pump and gauge to the vacuum hose that leads from the EVAP canister purge valve. Start the vehicle and allow the engine to idle, creating a suitable environment for inspecting the vacuum conditions. By using the vacuum gauge, you are verifying whether adequate vacuum exists at this point in the system. If a vacuum is detected, it signifies that the purge line on the engine side is clear, affirming that part of the EVAP system is operating correctly. If no vacuum is observed, it indicates potential blockage within the purge line between the EVAP canister purge valve and the intake manifold. Should blockage be confirmed, remedial measures must be taken to clear it before continuing with the diagnostic process. For the sixth and final troubleshooting step, it is essential to evaluate the performance of the fuel tank pressure FTP sensor, an important component in the EVAP system. Begin by turning the ignition switch to lock 0 and carefully removing the FTP sensor while keeping its connector connected. Utilize a T-fitting to connect the vacuum pump and gauge to the sensor for testing. After turning the ignition switch to on, 2, record the FTP sensor's initial reading using the HDS. Next, to assess the sensor's response, apply a controlled vacuum of approximately 1.3 kilopascals, 0.4 inch to the hose, being cautious not to exceed this value to prevent potential damage to the sensor. Verify if the sensor readings change in response to the vacuum. If a change occurs, the FTP sensor is functioning correctly, whereas no change necessitates a replacement of the FTP sensor. Following the completion of all necessary repairs, it is crucial to verify that the actions taken have resolved the DTC P0497 issue effectively. Start by turning the ignition switch to lock 0. Then reinstall all components in the reverse order of removal during the diagnostic process. After everything is put back together, turn the ignition switch to the on position, second position, to power the vehicle's systems. Reset the powertrain control module, PCM, utilizing the HDS, which clears any previous fault codes stored in the system. Lastly, perform the PCM idle learn procedure to ensure the engine runs optimally following repairs. To conclude the verification, select the EVAP test in the inspection menu and conduct a final function test with the HDS, confirming whether the results are satisfactory. If the DTC remains cleared, the troubleshooting process is successfully complete. To maintain the health of your vehicle's evaporative emissions control system and prevent future occurrences of DTC P0497, several preventive maintenance steps should be adopted. Regularly inspect key EVAP components, such as the purge valve, purge lines, and FTP sensor for any wear or damage, implementing any necessary repairs immediately. Always opt for quality replacement parts that meet manufacturer specifications to ensure compatibility and reliability. Additionally, keeping the entire fuel system clean can significantly reduce the risk of clogs and blockages affecting the EVAP system's performance. Preventing issues before they arise not only contributes to better vehicle functionality, but also ensures compliance with environmental regulations. In summary, DTC P0497 signifies low purge flow in the EVAP system, indicating potential issues that require thorough diagnostics to resolve. Understanding the roles of the EVAP canister, purge valve, and FTP sensor is crucial for effective troubleshooting of this code. Each step in diagnosing this issue, from checking connections to verifying sensor performance, is important for restoring proper vehicle emissions function. In addition, preventive maintenance steps can be taken to avoid future problems, ensuring reliable vehicle operation. Making informed decisions based on thorough diagnostics and taking proactive measures plays a vital role in maintaining emission systems effectively. Please like and subscribe to the channel. See you next time.